Now let's look at all the components one by one. And the first one is the data catalog and crawler. So what is this Glue data catalog? It is a metadata repository, or it can be used as a metadata repository for your organization. Now what I mean by that, so let's say your organization has various different data stores. You have MySQL database, Postgres database, Oracle, SQL Server, DB2, etc. And along with that, your organization also has various different data warehouses. Let's say Redshift is there, Snowflake is also there, and you're also using a Lakehouse using Iceberg or Delta Lake. And there are various different lakehouses available. Obviously, there is not only one lakehouse, and in the lakehouse itself, you have a lot of schema and a lot of tables. Same is true with OLTP data sources like SQL and NoSQL database. I forgot to mention NoSQL databases. It can be NoSQL databases also like MongoDB, Cassandra, DynamoDB, etc. And on the data warehousing side also, you have maybe thousands of tables. Because you have so many databases, so many tables, so many schemas, over a period of time, it becomes really unmanageable to keep track of what objects you have, what are the different data stores, and what objects are there. So what you want to do is that you want to have a single place where the definition of all those objects are stored. So when I say objects, it means tables, views, databases, etc. Using Glue, you can store information about all the objects across the different data stores like data lake, data lakehouse, data warehouse, SQL databases, and NoSQL databases in a single place. So that's why it is called a metadata repository, which works as a repository of metadata, meaning it works as a storage place to store the information about all the objects that you have across various data stores. And the other component that you see in the heading, which is Glue crawler, that can be used for data discovery or automatic data discovery also. Because Glue works as a single metadata repository, the schema management becomes really easy because you have all the schema, all the tables, all the definitions in a single place. Not only that, you can store column statistics also, and using Glue crawler, we can discover the schema of different objects and store it in Glue data catalog. There is an additional component of Glue which is called data quality. I'll show you that in the console, but I'll not do any hands-on. Using Glue data quality, you can do data quality checks. That option is also provided by Glue. Now, let's say your organization has various different data sources. For example, you have relational databases, then you have data warehousing systems like Redshift, you have open table formats or lakehouses as we call it, like Iceberg, Hoodie, Delta Lake, etc. You have S3, which is a data lake, and NoSQL database like DynamoDB. Also, you have other data stores. Let's say your organization uses multi-cloud strategy. So that's why I'm showing you Google Cloud Storage and Azure Data Lake Storage. Not only that, for data warehousing also, apart from Redshift, you have, let's say, Snowflake, Lakehouse, etc. Then there are other NoSQL databases like Cassandra, MongoDB, and other analytics tools like Elasticsearch. And Glue crawler can actually crawl all these data sources that you see. So what it would do, it would read the data sources and then store the schema in the data catalog. So the Glue data catalog and Glue crawler works hand in hand. We need a Glue crawler to read the metadata or read the schema from various different sources and then store it in the Glue data catalog. So this is the main purpose of Glue crawler and Glue DC or Glue data catalog, which work hand in hand. Now we have these other data sources like Google Cloud Storage, Azure Data Lake Storage, Snowflake, etc. For them, Glue crawler cannot connect directly, so you have to make Glue connections like login credentials, virtual private cloud, URI, endpoint, etc. And using this Glue connection, Glue crawler can connect to these different data sources and then store the schema in Glue data catalog. So when I say these different data sources, I mean the non-AWS data sources here. So that is the purpose of Glue crawler. Now the question is how Glue crawler gets to know the schema by just reading or connecting to these different data sources. Actually, a Glue crawler is nothing but a Spark job that we have already executed. So it is similar to Spark reading files with infer schema as true. And if the data sources are relational databases or data warehousing systems, then we do not even have to provide the infer schema true. Even for Parquet files, we do not have to provide any infer schema. But what I mean to say is that glue crawler is essentially a very small Spark job which connects to the data sources and then reads the schema and then stores the schema in the data catalog. So once the schema is read, we have seen the schema using the print schema API in Spark, but instead of doing a print schema, it formats the schema and then stores it in the Glue data catalog. That's what Glue crawler does. And not only that, we can add schema manually also, but in most of the cases, you would be using Glue crawler to read the schema and store it in the catalog. Let's see that in action.